All right, so we're back here for part 2. Now, looking at example number 12, we're going to have a problem here because the square root of 50 is not a perfect square. If I take the square root of 50, keeps telling me my batteries are low, I get a decimal because that is not what we call a perfect square. The idea of a perfect square, I'm going to come back to the power card here for a moment. When I take a number like 4, why is that a perfect square? Well, I can write the number 4 using 4 dots in the shape of a square. I can take the number 9 and I can write that, I can draw it as a square with 3 dots across and down as a 3 by 3 square. 16, I can do rows and columns of 4. So the reason we call this a perfect square is that we can literally draw a square to represent this amount. The problem with 50, or actually let's take a simpler example. The problem with 10, I can't draw that using a square. How do I make a square out of 10 dots? I can't. I can make a rectangle. I could do 2 and 5 or try something else, but that's not going to work. So what happens when our radical, in this case the square root, what happens when it's not perfect? Well, to simplify radical expressions, what this means is we have to pull out all the perfect factors. Pull out all the perfect factors. Now in this case, 50, again, is not perfect. However, if we look at our perfect square column, there is a number that goes into 50 that is perfect, and it's 25. 25 is a factor of 50. I can write this as 25 times 2, the square root. I can take the number 50 and rewrite it like this. Now, the idea of when we factor something is the factors are the numbers that multiply to a value. So the factors of 50, I can say, are 25 and 2. 25 is perfect. So one rule that we have with radicals is we are allowed, I'm going to write the square root of 25 times 2. When I have this as multiplication, I can actually write this as 2 separate radicals. I can do the square root of 25 times the square root of 2. Now this, we can actually simplify. That's just equal to 5 because 25 is a perfect square. Now the square root of 2 is still going to stay like it is. I can't simplify this anymore, and that's my answer. And just to show you, if I type 5 square root 2, that's the same answer. It's the same decimal. So these are equivalent values. It's just this expression is simplified and this is not because there's a number that goes into 50 that is perfect. So the idea of this is that we want to take out perfect square factors. That's how we simplify. If something that's left over is not perfect, and there's no more factors that we can pull out, then we're done. Now, one other way to look at this is if I take a factor tree. Let's say I didn't realize that 25 went into 50. What if I said, you know what? 50 is the same as 5 times 10. So I'm gonna do what's called a factor tree here, which is with multiplication. So 50 is equal to 5 times 10. Now 5 is a perfect square. I'm sorry, nope, sorry. 5 is not a perfect square. 5 is what we call a prime number. That means that the only things that divide into this number are 1 and the number itself. So I'm not going to keep going on the tree here because 5 is already broken down as much as it can be. We don't put decimals, so I wouldn't do, say, 2 times 2.5. And if I put 1 and 5, I'm just repeating this. Now the number 10 is not prime. We can write that as 2 times 5. Now 2 is a prime number and 5 is a prime number. Okay, so why have I done this? Well, the number 50 can be written with multiplication of all the primes. We can write this as a product of prime numbers, or a product of primes. So if I take the square root of 50, I can rewrite it as 5 times 5 times 2. And again, it's this idea that when I factor a number out, when I break it down into the primes, this is still 50. It's an equal value. I'm just changing the way it looks. Now, when I see the same number here, like 5 and 5, wait a minute. That's the idea of a perfect square. You take a number and you multiply it by itself. This is really 25. So anytime I have a pair of numbers here, I can pull out the pair, because the square root of 25, now I just write it one time. So when I pull this out of this radical, if I pull out the pair, I write the number once, because the square root of 25 is 5. Now the 2 is left over, I can't touch that, so the answer is 5 square root 2. Okay, so there's two ways to do it. The quick way is if you recognize the perfect square factor, but you can always do a tree as well. All right, so I'm going to show you this a couple of times. In number 13, now we have this outside number 7. We're going to leave that where it is. We're not going to worry about it. Let's take this. Let's take this number 80 and see if we can break this down. So if I use my power card here, the square root of 80, notice that 80 is not a perfect square. It's between 8 and 9. The square root of 80 is between 8 and 9. And yes, so it's 8.94. Now this is not simplified. When we round it, when we write it as a decimal, that's not a simplified expression. Okay, so since 80 is not perfect, are there any numbers here that are factors of 80, that go into 80? Now 4 would certainly work. If I take 80 divided by 4, yes, that would be 4 times 20. But if I'm going to do it this way, I'm always going to look for the biggest perfect square factor. Now 9, so I know that 4 works, 9 does not. How about 16? Now the square root of, 16 goes into 80 5 times. So actually 16 is a bigger number. So I think I'm going to use this. Now does 25 work? Nope. Does 36 work? Nope. Does 49 work? And a lot of these you can just do this in your head. So 16 is going to be the number that I'm going to use. All right, so we have 7 times the square root of 80. I'm going to rewrite this number 80 as 16 times 5. Now that's still 80, but now I'm going to use a perfect square. One of the other things here, when I broke this apart and I wrote it as 2 square roots, you don't need to do this. You can go straight from here and get your answer 5 square root of 2 for that. Excuse me. Now we have x to the third. Now what I'm going to do with x to the third is I'm going to write it out as x times x times x. The idea of a square root is we are taking out the perfect square factors. 16 is a perfect square factor. The square root of 16 is 4. Now we've got x times x times x. Since we have a pair of x's, that is equal to x squared. That's a perfect square factor. So if you have a pair of the same value, even as a variable, we're going to pull that out. The square root of x squared is just x. And then what we've got here, we still have an x that's left over, but because there's not another x, this is not a perfect square. Remember, a perfect square is a number times itself. Now, with whatever you have on the outside at the end, this is all multiplication. So this is 4 times x times 7. And what we get is 28x times the square root. Now, what's left over is 5x. And that's as far as we can go with that. If I had decided to do a factor tree, and let's say you know that 80 goes 4 times 20, and then we can break down the 4 as 2 times 2, and those are primes. I always circle my primes. 20 is 4 times 5. 5 is prime, and then 4 is 2 times 2. So you can actually go through this fairly quickly. It just looks, it's messy. Now when I write down all my prime numbers, and then remember we also had the x times x times x, and there was the 7 on the outside. We are looking for perfect square factors to pull out. A perfect square is a number times itself. So if I take this pair, there's a pair of 2's. The square root of, that's 4, is just 2. Now here's another pair. So if I have more than one pair, that would be another 2 there. And then a pair of x's, that's x squared. The square root of x squared is just x. And so what we have is 2 times 2 times 7, which is 8. We factored out the x. We simplified that. And then we still have on the inside, whatever's left over is just multiplied. That's 5x. And this is 28, not just 8. 28x square root 5x. Okay, so it's the same thing. Now the last thing I'm going to say here is that what happens if, let's say instead of the 80, what if I had used the 4 instead of 16 times 5? So what if I had done 4 and 20? Okay, I'm not going to do the rest of it, just these numbers here. The square root of 4 is 2. So we would get 2 times the square root of 20, but that's not correct because the square root of 80 is 4 square root 5. Now you'll see that 2 square root 20 and 4 square root 5 are the same, and those are the square root of 80. So those are all the same, but 2 square root of 20 is not simplified. So if I got to this point, I wouldn't be done. This would not be correct because I would still need, there's still a perfect square factor of 20. I could do 4 times 5, and the square root of 4 is 2. There's another 2 times 2. There's my 4 square root 5 right there, which is the same as this. So if you're going to use the power card, you want to make sure that you use the biggest perfect square factor to start. Okay, so let's take number 14 here. Now, if we multiply a square root by a square root, we can write that as one big radical where we multiply the inside values together. So what I call the outside, these are inside the radical symbol. We can multiply those together and we would get the square root of 108. Now this would be x to the 5th, and this would be y to the 7th. We add the exponents when we multiply, and now we have to simplify this. Okay, so now you could use a tree and break this down. I am going to use the fact that I know that 108 is 36 times 3. Now then we have all these x's here. I'm going to write this as x to the 4th times x to the 1st, and then y to the 6th times y to the 1st. And what I'm doing is I'm saying, okay, 36 is perfect. That's 6. X to the 4th is perfect. The square root of that is x squared. And then y to the 6th is perfect. That would be y to the 3rd. And so the answer is 6 x squared y to the third times the square root. Now what's left over is 3x and y. And that's it. All right, and again, where I'm coming up with the x squared and the y to the third, x to the fifth is x times itself 5 times. And then y to the seventh means there's 7 y's multiplying. To take the square root means to pull out the perfect square factors. Those would be the pairs. So here's a pair of x's, here's another pair of x's. That's x times x. And then we have 3 pairs of y's that we're pulling out. There's y to the third. And that is the end of part 2.